Hello, this is Jeremy Tyrrell from UNC Wilmington, and this tutorial is going to look at mapping social networks for your program. So we're looking at departments here or units within departments. As always, if you have any questions about this, you can go to my website, jtyrrell.com, and use the contact information there to get a hold of me. All right, so let's go ahead and start here. So the purpose in mapping these social networks, I think it has a lot of value internally for identifying valuable partners. So people with whom your program has investments and communication. This, of course, can be useful to demonstrate your investments and interaction with different kinds of networks. So this information can be used internally to find people who you are interacting with well, and those you perhaps need to make a greater effort or at least greater outcome in terms of communication. This also then can be used institutionally in order to demonstrate how your program is connected with all kinds of networks. Local community networks, scholarly networks, worldwide, those kinds of things. Externally, this, of course, can be used to foster community after graduation. So keeping in contact with your alumni and other people within a broader social network. And this, of course, can aid recruitment, demonstrating links to not only alumni, but also the broader academic community, the private sector, these kinds of things. In terms of what we're going to be producing, we're going to be looking at the maps themselves as network diagnostics, so identifying things like partners through the maps themselves. And this will be through different kinds of interactive tools that we'll be using. We will be outputting individual images suitable for print or electronic use. So, actually using the tools themselves will give us insight. We'll then also be exporting these into durable formats. Tools we're going to be using. So NodeXL is one we'll be using. That's it's an open source template for Excel, the spreadsheet program. And it has some different functionality that we'll look at. It's actually quite good, quite flexible. Its visualization capabilities are functional, but perhaps a little limited compared to some other tools that are specifically dedicated to visualization, such as Gephi, which is another tool we'll look at, and that's an open source. It's basically a visualization tool. You can give it all kinds of factors, and it can visualize things in different ways. The one in the middle there, Netvizz, that is a tool that we can use to collect data from particular services, in this case, Facebook. We're going to talk about this a little bit later because Facebook has recently changed its privacy policies. And so tools like Netvizz, which was essentially the tool for doing this, have been radically changed. We'll talk about this in a little bit, but it does have a really significant impact in terms of visualizing Facebook in particular. Most things relied on a combination of Netvizz and Gephi. We're talking about academic projects, commercial projects, but because of changes to Facebook, that's going away. This actually leads to, we're not going to have it right now, but a broader discussion about the nature of information, personal data, and privacy. In a lot of ways, what Facebook has done is positive because it's moving to protect privacy, but it also damages academic projects like this. So there's that sort of give and take. The author of Netvizz, the guy who coded it, actually speaks quite a bit about this. And we can look at that if we have time going forward here. So those are the tools we're going to be using, and we'll sort of talk about their caveats as we go. Anywho, so let's start with NodeXL. Let me pull this over. This is, you can download NodeXL. It's a social media research foundation project. Now, I'm not positive, but I think it actually started as with Microsoft. I believe Microsoft actually started this and then turned it over. Don't quote me on that. I should have checked before I started this tutorial. But now it is, regardless, now it is an open source project. So it's freely downloadable from their homepage. Once you load it, or excuse me, once you install it, it looks basically like this. It does provide a separate access point, so you don't just start Excel. It's actually a template. And once you load it, it looks something like this. Let me just cue that up. Oh, and let me pull this pane over a little bit. So this is what it looks like. So, basically we're working within Excel, but we do have this separate NodeXL tab up here. Everything else is probably familiar. And you can see we have our columns set up in some specific ways, and there are some different sections of the rib or the bar up here that are specific to this this template. So the first thing we're going to do is we're actually going to visualize a Twitter social network that doesn't have the same kind of restrictions as Facebook. And it's actually one that NodeXL will allow you to import automatically. So let's just go ahead and under import, we'll go to, you'll notice there's a couple options under Twitter, either a search network, which means we won't do that, but that's searching for tweets that match a particular query. So if you're looking at a theme, then that's what you would use if you wanted all the tweets about a particular topic. But we're looking at a user network here. So we'll go to from Twitter users network. The default here, you can actually enter multiple usernames. These are just the defaults. I'm going to be using an example one, my institution's English department, UNCW English. The first time you run this, you can see down here, I have a Twitter account and I have authorized NodeXL to use my account to import Twitter networks. You'll need a Twitter account. And the first time you run this, it'll actually connect to that account and it'll provide a numeric string that you'll have to give NodeXL. I've already done that, so don't be alarmed. You do have to be a Twitter user. I actually just used what's essentially a throwaway account, but that's fine. And then it'll allow you to select this option that you have an account and you've already authorized it. This will be grayed out to begin with, so you won't be allowed to do that. Now, in terms of what to import, by default, it'll give you the basic network and import only the Twitter users I'm interested in. And you can see the effects of changing these here in this little window. So right now, the sort of stripped down basic is replies and mentions. If you want a broader understanding of the network, you also get followers with basic network plus friends and followers. It says very slow, but it's that's relative. If we did this, it would actually be quite quick. Another option here is import only the ones I'm interested in. If you uncheck that, it'll branch off mentions. It goes to another level of mentions and replies and that kind of thing. What I'm going to do is actually, if I give you the default here, only the people you're interested in the basic, if we pull that up, it's actually for this account, it gives us basically nothing. Let me show you that. This is just a note about wrapping the text. So this actually looks like quite a bit because these are tweets, individual tweets, but they're all from that account and essentially to that account. So these are our edges or our paths. These are our vertices. You'll see there's only one node. If we visualize this, which we can do in this pane over here, I'm just going to drag this over and click Show Graph. We can also do it up here in the bar. But you can see it's just this ring. So that really tells us nothing. So I'm going to go ahead and re-import the data. And it's set up here under import options to clear the data when it's imported. So I don't need to make any changes here. It's just going to replace this data. So I'm going to do that again, but I'm going to change some of my options there. If I do sort of the broadest thing, get people I'm supposedly not interested in and a broader notion of the network, then I'm going to get a whole lot more. It doesn't take that long, really. Now if I refresh my visualization, you see I've got kind of a cluster here. These closer vertices or nodes, depending on the language you use there, terminology. This will give me an understanding of who these people are that are in tight connection with me. So not followers of followers or that kind of thing. And you can see, this is not surprising to me. We have the Seahawk, which is our, it's a newspaper publication that's on campus here. Our library. So no big surprises there. This might be what I would work with if I wanted to use this for external recruitment purposes, showing sort of a broad notion of network. So these are connections, but some of them are a little bit farther away. So this might be good to sort of show breadth, right? But if I wanted to actually see a tighter notion of connection, there's lots of things I could do. I could filter this out. I could change my visualization to give me a different notion of proximity. And I could filter out ones that perhaps aren't as close. Or what I could do is just pull a different notion, or excuse me, pull data that's closer. So I'm going to go back to our, but leave this unchecked. Okay. And so if I change this back to standard, I'm not going to pronounce that. You can see now I've got a much tighter notion of network. These are entities to which this account is closely aligned, at least relatively. So this is something I would use to identify those kinds of things for internal purposes rather than external purposes. Now, there are a couple of useful things we can do to clean this data even further. One thing I'm going to do actually is you'll notice a lot of these, and we're on the edges tab here. Edges are these lines. They're essentially connecting the vertices. And you'll notice, by the way, it's grouped here. A lot of these are from this account to this account. And that's what's causing this ring here, kind of in the middle of our visualization. Let me drag that over further. And I'm going to get rid of those actually completely, just because I don't need that information. So I'm just going to get rid of these rows. And now it's, only a few really. And you can see there's some repeats in there that we'll look at in a second here. Now, when I refresh, you'll notice that ring edge is gone. In the vertices here, this is a list of the vertices or nodes, and we'll return to this in just a second, but we're going to look at the edges first, because you'll notice there are some repeats, right? But they're only getting technically counted once. So there are multiple, and we can see what it is, replies and mentions of this account to this other account. Vertex 1 being the center, vertex 2 being who replied or who mentioned. You can actually see the relationship and the tweet itself, right? So here's a reply, here's a mention. Whoops, sorry, my hand's on the wrong place on the keyboard. Some of these are retweets, some of these are other mentions. So how do we kind of collect that together to show that relationship in the vertices? We can go up here to prepare data, which is under this data section, and notice it gives us some really useful options here. So the second one we don't really need, get vertices from edges worksheet. We've already got the vertices. But this count and merge duplicate edges, this will be very useful because it's going to collect all of these multiple tweets, as it were, into a notion of weight. And then it'll change our line, our connector, our edge, based on that. So I'm going to go here, and it gives us some options. We don't have to futz with this too much, but notice by default it'll have vertex 1 and 2, which is what we want. It'll have count duplicate edges and insert the counts into an edge weight column. So let me just show you that really quickly, and I'm going to sort of drag this visualization away. You can see we have all these different columns up here. color, width, style, opacity, all of those, you actually have to set something in those columns to have it reflected. So I could do this manually. I'm not going to. But if, for example, we wanted this line, which is the, it's this account, this cropped lines connecting to the UNCW English account. If I wanted to make this width a lot more, you can see it says enter something between 1 and 10. So if I put 5 and I refresh, see how that size jumped way, way up. So we're on a scale 1 to 10 here. But notice that in order to change that, you have to have data in there. That's what is being reflected here in the visualization. We've got some other columns here as well after where it says add your own columns. And those are things like the kind of relationship, a mention or a reply, the tweet itself, and then some other things like a link to it, date, and that kind of thing. But the point of this is we want something in this width that's going to visually demonstrate a value, right? So I could go through and manually count these and put that in the width. You know, we did that kind of thing before when we were making some of the other visualizations, but this prepared data will do that for us. So it's going to count up the duplicates and put them in a new column called edge weight. So that'll be great. And then we can also optionally merge the duplicates into a single one. So instead of having these multiples, it'll merge them down. You may or may not want to do that because it could lose some of that individual tweet data. That's why it's not automatically checked. So I'm going to leave it because it's actually not going to really change our edge weight. So I'm going to go ahead and do that. And now you'll see it's added this edge weight column over here. So everything that is going to the same account is the same. It doesn't add these totals up or anything. That's for this account what the edge weight is going to be. You'll notice it hasn't changed anything because it hasn't moved that edge weight column into this. So we need to copy that data over into this. And the way to do that is go to autofill columns. That's set up precisely to do that thing. So we've got tabs here under edges, vertices, and groups. We don't have anything in groups. So we're dealing with edges now, and we want to deal with the edge width. And it's asking which column should we move, should we populate edge width with. And we want this new edge width column. We're going to click here under options. And this will let us tinker a little bit with how this is going to appear. So right now, the smallest number, whatever it is going to have an edge width of 1. And the largest, whatever it is going to get an edge width of 10. We can ignore outliers. So if there's, outliers, something that's unusually large, it'll ignore that. And we can use linear or logarithmic. By default, it's linear. But let's just stick with this default and see what it looks like. We're going to click autofill, and it's actually going to reflect in our visualization automatically. Okay, whoa. So right there, we're getting more than we want. I mean, these sizes are larger than we want. So let's change that a little bit. Going to go to the options here. And it's not giving much relative data, or at least not as much. So let's see what happens if we change this to 5. The largest is just 5. Okay, that's much better. Because then even our largest one, we might even tweak that down to maybe 4. And then repopulate. Yeah, because then even our largest is still, legible. Okay, so now we have the width, and you can see over here, the width of the edge or line connector is based on the number of connected tweets. So we have that. Now we want to move over into the vertices or nodes, and we can represent a lot more data by varying aspects of these as well. So here, for example, we have columns based on followed, followers, number of tweets, favorites, those kinds of things. Why don't we reflect some of that in the vertices or the the nodes. Now, similarly, if we want to do that, we have to put some information here in this size. We're going to go back to autofill columns. Now we're going to click on vertices, and we're going to use vertex size. We're going to get that data from, and you'll notice there are a lot of options here, but not all of these columns exist. Notice it says here in the pop-up if these columns exist. Why don't we reflect the size of the vertice or node? Why don't we do something like followers? So this will give us some visual indication of how popular, as it were, this account is. And let's set this at 1, and this is to 10. Let's see what we get there. Okay, now this is interesting because, and you can see here in our size, most of these are 1, and then we do have an outlier, the U. Oh, I think that's the UN. It, you can see on the visualization, is quite a bit larger. So we're not getting too much useful from this. So that's actually good for our purposes because we can tinker with the options and see what they do. One thing is, let's just check ignore outlier and see what kind of range it gives us. Okay, now see the variance is quite a bit more because it basically discounted UN here because that one was so much higher, and it went to the next highest, which was WECT News. It's a news station here. And now it does equate those two things, which is a little unusual. We could go in there and manually bump up the UNs to reflect that it's much bigger. But you see, we have a better range here. So we might just stick with that. Just for giggles, let's also check what happens if we use logarithmic rather than linear mapping. Okay, now we actually, this may ambiguate it. That may not be too useful because the difference in size is maybe too close, which can happen when you use a logarithmic mapping technique. So let's go back to just ignoring that outlier. Yeah, or let's use a logarithmic, but don't ignore that outlier. Okay, that's actually pretty good. And we don't have to do any manual tweaking then because it includes that one really large one. It's still largest, it's 10, and the next is 6. Yeah, but it gives us a nice sort of sense of scale, right? Ones that are 1 are still small, but it gives us a nice middle, as it were. And we could bump up this vertex size because this is still pretty small. We can go even up to, say, 30 and get triple the size. And it still then sort of brings into relief what's small and what's larger. Okay, so that's useful. Now, another thing to consider is something like, well, what about adding more data through an axis that we haven't considered, like color, right? So let's go to this vertex color here and select something like, oh, how about the number of tweets? We'll go to options here. And it gives us this nice spectrum to do something like that. And I've always thought this is unusual. I mean, again, we're talking about the same variable here, number of tweets. Why would we have 2 colors? That's always struck me as odd. So why don't we use a custom color here? Let's crank it up to red. And this is basically the reddest red you can have. Well, almost. But this is our minimal color. So what we'll do is just tweak the luminosity of that down to, yeah, just a sort of mild red. That's good. Actually, very low red, I'm sorry. And then we'll tweak this up to our maximal red. Yeah. Okay. And now if we autofill that. Okay, so now we have colors based on number of tweets. And you can see those who have tweeted quite a bit. And again, we could change this to sort of ignore this one. And, you know, this gets into sort of a question of, do we want to make sure we're consistent, you know, always either ignoring the outlier or always using a logarithmic map? Those are questions of representation. We don't want to be disingenuous, but because these are different variables, those can be presented differently, I think, without any intentional deception. Okay, and now we've got a nicer scale in terms of who's tweeting a lot. That's the color. Who has a lot of followers, that's the size. And then a notion of who we are connected closely with based on the width of the edge itself. Okay, so a lot of different variables there, and this does help us identify things. Now, of course, the last thing to do is we could either, you know, just individually click these and see who these people are, or we can just go ahead and put the labels on there. And to do that, we are going to have to go back to autofill columns, vertices, vertex label. We need labels. We're just going to copy the data over from vertex 2 here. Okay, and now you can see it's given us the labels, and those are colored based on those same parameters. So you can see sort of who's popping, right, and who's not. But this does give us some useful information, right? For example, this one, UNCW, that's the cake office. So we don't have a great connection with them, yet they're fairly large. You know, they have a fair number of followers, and they're quite red, so they tweet quite a bit. WECT News, so our local news station, again, we don't have too much of a connection with them, but they have quite a number of followers and they tweet quite a bit. So this does identify perhaps people, or, you know, someone who's larger but doesn't tweet so much, doesn't have a lot of followers. What this does let us do is see, you know, perhaps places we could target. You know, this is somebody who tweets a lot and has a large number of followers, but we don't have a big connection with this account. So maybe that's someone we can target, or someone we can perhaps leverage. You know, someone like the library. We can leverage our clearly strong connection with them, or with our local newspaper here. Okay, so that's how we can use those internally. We can now, and I can drag this this over to here, export this as an image. I'm just going to right-click and save image to file. You can see we have image options over here. And when we export this, there are a couple of things to talk about. One, we probably don't want this footer. Maybe you do. I don't, because I just want the clean image. This width and height, those are pixels if we're dealing with a raster image format. So you may want to set these really high. It only goes up to 5,000. And since height is my my main unit here, and you can see when I have this checked to preserve the aspect ratio, I can't go beyond 5,000. If you try it, it doesn't let you see, it just cues back. So this would be sort of the largest one. Why I would want to do that for a raster image is so that I could use that physical size. I could scale up the resolution, scale down the physical size, and not lose too much. The good news is, though, this can export into a vector format, which generally, of course, we always want to use because it has, you know, essentially infinite resolution. So we will save image here, and instead of using one of these raster formats, let's use XPS, which is a vector. I'm going to save that to my desktop as, you know, Twitter map. Okay, and there we go. I think that's just super large. Yes, it is. But this is a vector, of course, so we can print this out. If you wanted to use this online, you'd probably want to go ahead and just export in a, you know, a ping or a GIF. You probably wouldn't use a JPEG for this because, you know, JPEG's a lossy format. But if for printing purposes, we'd probably want to use a vector. And then from here, you can export to a vector as well from something that can open an XPS. This is just a viewer. All right, so that's that. And you can kind of see how it works to identify these folks. We could run through the same process with that much larger network. What was it? Yeah. Yes, and it's going to replace this. We could run through this same process that I just did with this larger network. So we'd get a sense of, okay, and we'll autofill the width here. Oops, we actually probably need to change that now because we're dealing with so much more. That's 1 to 4. What if we change this to 10? Yeah, actually, we probably need to scale it back. It's just because we're zoomed out so far. Which you can change that that visualization here under layout options, and you can change actually the visualization you use. Let's change the size here. Yeah. But we'll keep that. Let's zoom in here. So now we can, woo. Now we can see sort of the network we had before mostly is in here closely clustered. Then we've got these other outliers. For this, we probably, let's change, because I think we were using a logarithmic. That's probably not doing us any favors right now. Let's see if we don't ignore that. Yeah, then they're too similar. There we go. You can see, remember our outlier was up here. We can see sort of the network we had before, but we also get this richer sense of breadth. So this is something I might do for recruitment purposes or something like that, or showing breadth. But for identifying power nodes, it is perhaps a little bit of overkill. So we could do that depending on our purpose or rhetorical purpose. We can do something similar for a YouTube network, a video network. This is the default one. Now, one quirky thing about this is a lot of accounts for YouTube, it's just not going to work. This is the default one. It'll work. Something like, in fact, my university's account, it won't work. It's private, so it'll tell you. It won't import the data. This default one will. I just made it a little bit larger. I went to 1.5 levels. But we could do something similar. I'm not going to walk through it, but it works fairly closely to what we just did. You can see this is the YouTube graph, but we can do pretty much the same operations to draw out the sort of distinctions in this. Now you'll notice up here under import, it does have the option for Facebook group network. That is because I have used the NodeXL social network importer. It used to be a fantastic tool because you could download this. It's a plugin basically. And then you had the option to import groups, pages, and personal information from Facebook. However, because of recent changes, it doesn't function anymore. It doesn't give you the data anymore. You can try, but it'll throw up an error. There are notices about this on the corresponding website, but they haven't been addressed. Oh, and it looks like it's hanging. So as of now, there they are. It's talking about these are the errors you'll get. Let's see, when I try to import Facebook data, blah, blah, blah. So unfortunately, and this is almost certainly, there hasn't been an official word yet, but from NodeXL, but from other services such as Netvizz, this seems to be due to the change in Facebook's privacy policy. So unfortunately, although that used to be fantastic through here, it's not quite as useful. Let me kind of walk you through the other tools we were going to talk about, Netvizz and Gephi. They're both great tools, but because of those changes I just mentioned, right now they're not super useful for some of our purposes. But let's go ahead and take a look at them anyway. This is Netvizz. Let me just pull that up. And this is an app that you can get on Facebook. You just have to search for Netvizz. And it does function, but it makes nodes anonymous. So let me show you what I'm talking about. We're going to do the group data. And this is the process we would walk through. It's still useful, but some of its utility is curtailed by the anonymous aspect of it. Now I'm going to pull up here. This is an example group. This is my institution's Department of English here. I'm going to want just that ID, which is just this number. And there's some different options here, interactions or friendship connections. I'm going to use that one. So it'll process that. And if that takes too long, I've prepped one in advance anyway. Yeah, let's see if, because this can sometimes take a couple of minutes. Yeah, here it goes. I've prepped one in advance. Let me just pull that up. Yeah, it eventually, you basically get a GDF file. You just have to, as it says, save as. What you get is a file that looks like this. And this works with Gephi, which is an open source. Whoops, let me just find the right tab here. Got too many pulled up. It's this. It's an open source visualization platform. You can do a lot of stuff with that. We're just going to look for a little bit because, as I mentioned, its utility is a little bit limited for us. Oops. Again, open source, just download it, install it. You'll get something that looks like this. And what I'm going to do is go ahead and open up that file that we downloaded from Netvizz. Okay, and this is what it looks like, just kind of a spaghetti. And before we actually start working with this, this is the person who programs Netvizz, and you can see just the start of this year how the change in Facebook's privacy policy led to these sorts of changes. And, you know, it's an interesting discussion about privacy and who owns data and that kind of thing. And he discusses the impact on these kinds of projects, these academic projects that rely on this and research projects. His name is Bernard Reeder, I believe. I think he's in Amsterdam. So hopefully I'm pronouncing that right. Of course I'm not, but I'm doing my best. So this is what we kind of get, and we can actually work this into something useful. Now you may have seen those personal Facebook network visualizations like Touch Graph or something like that, or even Friend Wheel that show you these kinds of things. This is for a group or a fan page or something like that. I'm going to just kind of quickly run through how we can pull out interesting data in this. The first thing I'm going to do is change the layout. I'm going to use Force Atlas here, and there are some different options. And if you have questions about this, just contact me through my my contact info on my webpage. But we're not going to pour over this because this is a sophisticated tool. So there's lots of things to kind of tweak. I'm going to click Run, and you'll notice the visualization changes. I'm going to stop it now. It'll keep running, kind of pushing things in a different direction. Now I'm going to actually kind of sort out some of our nodes here. I'm going to zoom in just a hair. Here they're called nodes instead of vertices. We retain edges. I'm going to change our nodes based on degree, and I'm going to change the color here. And I've got it set up to go from basically a very light red to a very dark red. I'm going to apply that. And you can see we've got 66 levels here in our range, which we can tweak. The very red are close ones. We can see these outliers are probably not very well connected to us, to that group. Okay, now let's look at changing the actual size of the nodes here as well. So I'm going to run a few things over here in statistics. I'm going to run the average path length. Okay, and I'm going to go back to nodes here, and I'm going to change the size of nodes based on what's called their betweenness centrality, which is a measurement of importance or activity in this network. Now, instead of changing the color, I'm going to click this other one and change the size. So let's see, it's ranging from 10 to 100. That's too large. Let's change that to, say, 50. The smallest will be size 10. The largest will be size 50. And you can see the range is from 0 up to over 1,000. Okay, so now we've got a pretty good range here. I'm going to pop that up. Let's say 70, and let's see. Maybe we can do 100. Okay, now all these nodes are overlapping. That's not super helpful for us. So I'm going to go click this thing called Adjust by Sizes here under Force Atlas and click Run. Boing. So now that will stop them from overlapping, and you can see different nodes and how they're connected together. A couple other things I want to do. Everything's red right now. I actually want to change that into different sort of modules or sub-networks within this network. So I'm going to run this statistic over here called modularity. And now if I go up here and click on edges rather than, on partition rather than ranking and refresh, modularity class is an option for partitioning off parts of this large network. And what it's done is it's given me these random colors of different sub networks within that. So if I apply, okay, now we can see all these different networks. We can see the purple connected, the teal, which is one of my institution's colors. That's just a coincidence. That are connected within this large network. We can also filter this a little bit. So I'm going to click on filters over here. And under topology, there's degree range. So that's degree. That's that first thing we dealt with, sort of number or importance in terms of connections within this network. I'm going to tweak this range down here. So let's see when I move. I'm going to apply the filter. So those perimeter folks, they're already out at 1. Let's keep going up. I'm going to get sort of a thinner notion. Now see, I've lost some of these peripheral connections. So I may want to retain those. If I just want to see who the heavy folks are, I can keep going up here. And then what I could do is click this over here, which is my label. And this would be the folks in the, and let me scale that according to, well, not node size. The folks who are well connected within this network. You'll notice right now it's just providing a random string for the user. That's the change, and that's the sort of issue now, is this used to provide who that user was. Now it gives us an anonymous user. So its utility in terms of identifying folks is limited, What it does still do is give us a great notion of sort of the breadth of this network. And so it could still be useful for recruitment purposes. And we could, if we wanted to, go here under preview and refresh. And there's the connections of our network. We can export over here under export. And here, again, we can export things as a vector format like SVG, raster like ping, if we're going to use this online, or a PDF. So that, I believe these are also going to be, PDF can handle both vectors and rasters. And I believe it exports as a vector. So I'll call this, Facebook map, that on my desktop. Yeah, that's fine. So here we have our Twitter map. Here we have our Facebook map. And there are some basics of social network mapping. So a few tools. We are just in an interesting point right now that Facebook, which is such an integral social network, its notions of privacy are shifting, probably for better in terms of the individual, but it does complicate these kinds of issues of how do we track major connections in a social network like Facebook. The good news is we can always triangulate with things like Twitter and YouTube using some of the other strategies we talked about. But certainly this is something that's going to be relevant going forward. As I said, Netvizz and Gephi are kind of the go-to for this sort of project. So now that things have changed, it'll be interesting to see where things go. We're at a moment of transition. If you're interested in any of that, feel free to contact me, or if you have questions about any of this. As always, you can do that through my web address, jtyrrell.com, and then my contact info is there. All right, that's it. I will see you folks later, I suppose. All right, thank you.